All right, welcome back, friends and neighbors. Of course, we're talking about EIGRP in this series, and today we're going to chat a little bit about messaging and packet types, or at least the ones that'll get us started. Now, to begin with, there's a couple of routers that we're capturing in between, and they're just sort of talking to each other. And as I got this configured, I was just, capturing along the way. And so right away we can see there's a couple things here. One is that the two routers involved, 2.253 and 2.254, were having really a multicast conversation, so they weren't actually talking to each other. This is that discovery process. And then eventually they figure out each other are there and want to do some EIGRP. And so later on we'll see what happens when I start to actually get them configured in the same way. But there we are. There's our initial conversation, right? We start with the hellos, and then they actually start talking to each other. So that's what we get from this particular set of packets. Well, it makes sense to begin at the beginning. So, of course, the first packet type that we see is a hello. And this is the first part of the process. Remember that EIGRP has a discovery process, and then also recovery where things are broken and we want to find everybody or we want to find each other. So the hello message or the hello protocol is used for discovery. Now, as you saw, it begins with multicast, and that's going to 224.0.0.10, and there's no acknowledgement required when it's just doing the multicast, so the routers are just really trying to find each other. Now, this happens as soon as you turn EIGRP on, and so the interface that's enabled, well, that's a little misleading because a lot of this stuff doesn't happen in the interface or on the interface. It happens in the global configuration, and so you're just really saying, well, I am going to have a couple of interfaces with IP addresses on them, and then I'm going to tell the router to advertise those networks, and that's when you start seeing those hello messages come out. Now, we'll talk later on about metric K values, but as you know, EIGRP is a distance vector protocol, and so the routers have to figure out what metrics or how they're going to do their actual calculation, and so they're going to include some K values. And routers will only really become neighbors with each other if they have the same way of calculating the metric. Here is a look at the topology upon which these packets were discovered. So we've got a couple of networks here. So here's the 1 net all the way on the left, and then the 2 net, the 3 net, and the 4 net. And where I was capturing traffic is right here. So I was working at first on these two routers, router 0 and router 1, and then later on I'm going to add another router to the topology so that we can see the updates that go. There'll be updates for the other from these two before that happens, but I'll add this guy later on. Now, what would a video be on this channel without actual packet captures? So I've got a bunch of things highlighted here. First off, we see that we are using that multicast address. Now, this is a multicast address that's reserved for EIGRP. RIP-v2 and OSPF have their own reservations too, so routing protocols use different addresses. So the only ones paying attention to this multicast address are routers engaging in EIGRP. Now, I put a little star right here. Isn't that a nice little star? The reason I put that there is because there's no layer 4 protocol. So a lot of routing protocols, I won't say a lot, I mean, it's not like there's a ton, but routing protocols don't always have a layer 4 protocol, so no TCP or UDP. There's our opcode that indicates that this is a hello message, and this is also how Wireshark knows how to start to decode it. Now, we will see later on that sequencing and acknowledging is important, or the numbers are important to EIGRP. So when you're sending an acknowledgement, a receiving router understands what in the world you're acknowledging because you sent a message with a sequence number. There's our K values, and these are the things that we want to ensure are the same between the routers. And then lastly, I've got a hold time down here. Now, this is significant. There's two things about this. One is, you saw that there were a lot of hello messages. Hello messages come out about every 5 seconds, and so the hold time is 3 times whatever your hello time is. So this is how long a router will sit there and wait for you to chat. If it doesn't hear from you for 15 seconds, it thinks something's up and will reinitiate the discovery process. Then the next message, or there's two messages that we're actually going to chat about, are two things happening. One is an update and one is an acknowledgement. And the first one here is an update. The minute two routers discover that they're neighbors, meaning that they found each other via hello and they agree on the K values, then they're going to send each other updates. And the whole point of updates is to convey destination reachability. So really we're talking about reachability to networks. Now, if there are minor changes to things, then we might use multicast. But no matter what, updates are going to be reliably transmitted. Now, for EIGRP, what reliably means is that I want to hear an ACK from you so that I know you got it. And it's typically going to be unicast as well. And of course, we saw that initially we start off with those hello messages, we figure things out, and then we start sending updates to each other. Now, if it's the very first set of updates, we're going to include an init flag, meaning that there's no real routing information included, just a sort of update about the network, and it's called the null update packet. And we'll see here in a minute that there's an actual init indication in there. And what this really does is not only say, hey, listen, this is the first time that we've started talking, but also, hey, send me your updates because I agree with how you want to do things. And here is an example of an update packet. So this is from 2.254 in this topology, right, going to 2.253. So this is unicast. And we're now seeing a couple things. We've got our init flag set saying, hey, look, I agree with you. Let's exchange topology information. And then we've got a sequence number here. So one configuration detail, at least on Cisco, and since this is largely Cisco EIGRP in RFC form, when you set up OSPF, for example, you do router OSPF and then there's a process ID. Well, in EIGRP, it's an autonomous system value, and everybody's got to have the same autonomous system. So as I was bringing these up, I was futzing around with autonomous systems, and once the figuring out what I wanted to do, and once everybody agrees on the autonomous system, meaning that they're all in the same autonomous system, because really that's what EIGRP is all about, then you see this flurry of activity, and then we can see that we've got this is about the 3net here, and that it's an internal route. So that makes sense, part of the autonomous system, and then it's about the 3net. We've got sequencing starting to happen and an autonomous system value. Now, acknowledgements usually take advantage of something called piggybacking. Piggybacking simply means that the hello message is actually for telling your neighbor that you're still alive. So it's a discovery and recovery process. But you can make an acknowledgement by including an acknowledgement number in there. So this is actually a hello/acknowledgement of that very first init update from the other router. So you can see that this is from 2.253 going the other way. And then just for fun, what I did was included that router, the third router, router 2 by packet tracer code. Now these packets were not actually caught in packet tracer. Packet tracer is pretty awesome, but it doesn't do packets as well as you do on the network. So this was, the topology diagram is what I did in the lab, really. And here we have an update for the 4net. So again, this is from 2.254, so the sort of right side of the topology. And the minute I brought up the 4net and made everybody part of the same autonomous system, then what we see is that this was a little later on in the process, right? The sequence number was 8, but this was piggybacking an acknowledgement number for an earlier sequence number. And of course we can see the opcode is a 1 now. It's an update message, so a different kind of message again. Autonomous system is 1. Here's the 4net, right? Now here is network topology information. Here is the metric. We'll talk more about those later on. So there we go. Now next hop, all zeros here. Now there is no default route in this. That's not really what this is about. When you get an update from your neighbor that says I can get to this particular network, right? So this is the middle router saying, I now know where the 4 network is. Then the router all the way on the left-hand side of this topology uses the advertising router as its forwarding router interface. And so this might be a little misleading, but this is not actually going to be what the real next hop is, right? This is from 2.254, and so this would be the forwarding router interface right here, or the forwarding router's IP address. And here is a look at what the middle router's routing table will look like, right? We've got 2 directly connected networks, right? That makes sense, the 2 and the 3 net. But we learned the 1 net from 2.253. That's this interface right here. And we learned about the 4 network from 3.254, which is this interface right here. And that sort of makes sense. And a D at the beginning, I know it should be E, but that has a different meaning. Means EIGRP. And there is how long we've known about this, right? So that shows you my delay in getting this router up and running. Well, hey, this has been a little bit about EIGRP messaging, at least the initial part. So we got some hellos, some updates, and ACKs. And even if you're not doing EIGRP, this is a similar process that other routing protocols go for. All right, your EIGRP is growing. We'll have you out of that pot and full size in no time. Thanks for watching. Thanks for listening. Like and subscribe if I helped. And hey, may those EIGRP packets always reach their destinations.